In this video, we'll look at question 13 from the second paper of the 2017 exam. So in this question, we are given three numbers which are in standard scientific notation, and we know that they satisfy this equation. And our task is to say which of the following four statements must be true. Before we delve into this question, let's just clarify what's meant by all this standard notation business. Those will be numbers like 6.67 times 10 to the negative 11, which is the gravitational constant, or 1.7 times 10 to the 2, which is just 1700. But what would not be standard notation is if any of these numbers were bigger than 9.99999 or smaller than 1. So say 1000 times 10 to the negative 11, that's not standard form. So that was just to clarify, and let's now go through these conditions one by one. And to help us with that, I will introduce some notation. So the first number is 0.00, and on the third decimal place, the number A will start. So I'll just put A bar for that. Then similarly, for B, we just get 10, and on the second decimal place, oops, that was meant to be in green, B bar. And when the two are added, they should give us a number of the form C bar. So does A need to be bigger than 9? Well, not really. Just consider if I had 0.001, then I could just make the choice that B will be 9.99, and these three together give a number of the form just C times 10 to the negative 1. So A can be arbitrarily small. So A is not true. That, however, won't be the case in B. Let's just try and make B as small as possible as to still satisfy the equation. So if we want B to allow to be really small, then we should make A really big so to make up for it, and to still make this sum be a number 0 point something immediately, followed after the decimal point. And the biggest number we can choose for A is 9.99999, and then in order to get at least 0.1000, we'd still need for B a number just slightly bigger than 9. There would be a 1 somewhere at the end of the number. That makes no sense, but you know what I'm trying to say. So even if we try really hard to make B as small as possible, it always has to be bigger than 9 in order to satisfy the equation. So B definitely must be true. And the remaining two options basically say that either A or B needs to be smaller than C. As we already know, A can be anything up to the biggest value which it can take, something like 9.999. And in that case, it is even impossible for C to be bigger than this number. So not only is C not a requirement, it might sometimes even be impossible. So that's definitely not what we want. And if we already know that B has to be bigger than 9, and we have seen that C can take values like 1.0, 1.1, then clearly it is not the case that C must be bigger than B. In fact, we could prove that the opposite is true. So that's not what we wanted, and therefore B was the only correct answer, and the right option to pick in the answer sheet.